What's going on, guys? I wanted to share with you a project that I'm working on. This summer I'm going to be attempting to renovate an older well on my property. This well was built in the 1800s and has stood largely unused probably since the 1960s or so, and it's in desperate need of repair. I do have a secondary well on my property, which is the primary well that I use, and that utilizes a submersible pump. In a long-term grid down situation, that pump's not going to be it's not going to be running. I only have a limited amount of fuel for my generator. So my goal is to develop this older well into an emergency water source for my home. And to do that, I'm going to use what's called a bailing bucket or a well bucket. So the basic idea is that you have a bucket that goes down inside the well shaft, and once it goes down into the water, there's a check valve at the bottom that opens up, allows water to enter, and as you pick the bucket up, that check valve closes, keeps the water in until you pull the bucket up out of the well and use it for whatever you're going to use it for. Now the problem being is that this well shaft that I'm attempting to use will not allow a conventional bucket to fit down inside of it, so I'm going to have to construct my own well bucket out of PVC pipe. And this is actually a common problem for modern wells too. Most modern well shafts might be about 6 inches in diameter, and you will not be able to get a bucket like this down inside to fetch water out. So what I'm about to show you here could actually be used for your more modern water well in an emergency. So to begin, I have a 3-foot section here of 3-inch diameter PVC pipe. This provides me about 1 gallon of water if you do the mathematical formulas to determine what volume is. This is just about 1 gallon of water, and you determine that by taking the radius squared, radius meaning half, from here out, diameter is the full, radius squared times the height times pi. Pi is 3.14, and you'll come out to just around 1 gallon of water, which is 231 cubic inches. Not exact, but it's close enough for my purposes. But the major component of this is the check valve at the bottom, and that's really the meat and potatoes of this video, is how to put together this check valve. Now what I've done is I've taken a 3-inch, if you can see that, I've taken a 3-inch PVC cap, drilled a series of holes all around here, hole in the middle. So what I'm going to do is I'm going to make a little check valve out of this by taking some rubber. This rubber here, you can pick this up at Lowe's. It's called plumber's pack. It's a 6-inch by 6-inch by 1/16 of an inch thick rubber sheet. And what I've done is I've cut that into this 3-inch diameter disc. I have a carriage bolt here. This is a 5/16 carriage bolt. I'm going to feed this through this hole. I don't know how well you can see this because I have a sun glare on my lens here. And I'm going to put that little rubber flap that I made, excuse me, I screwed up. I'm going to put the carriage bolt through, and I'm going to take a 5/16 nut, screw this down in just about where it's level to this rim. I'm going to take a fender washer, 5/16, put that in, then put in my rubber gasket flap valve here, and just repeat the process. Another fender washer, and another nut. Now all of the hardware for this, it is stainless steel, so it's very rust resistant. So what this does, once you tighten it down, you can see how that, if you press on this, you see how that moves. So what happens is, and I'm going to turn the camera over here to the water. Hold on a minute. So what happens is, you put this down into the water, all of those holes will allow the water to come up through. And as soon as you pick this up into the air, as soon as you pick this up into the air, that rubber gasket comes down and locks up those holes, so no water is escaping. I apologize, guys, if I have this these items kind of going off screen here. I have a big glare on my lens on my screen, so it is hard for me to see where I am positioning things, but I'll do that again. Put that in the water. You see it's filling up. And it empties. Another way to empty it is you could just push up on that the bottom of that carriage bolt. It empties the water out. So this is really the meat and potatoes, you know, of this entire well bucket. So I'm going to zoom out and try and show you the rest here. Because from here, all you would really do is just kind of put this onto the end of your 3-foot section of PVC pipe, glue it in place, and you essentially have a well bucket. And at the other end, you can see I've taken a 6-inch threaded rod and just bolted that into place. I have 2 bolts on the exterior. From there I go to a lock washer, then a fender washer, then I have 2 bolts in the interior. So this thing is not moving anywhere. This permits me an area where I can hook a rope to and lower this down inside of my well shaft and fetch water out. And I'll just prove that this works just by demonstrating on this bucket. So that goes down inside. The water fills up. I pull it up out. And it works. Very simple device. Now these other components that I have lying here, this is actually for more long-term use. If I would ever need to perform any maintenance on this check valve, and I have it glued in place just the way that I had shown it, what will happen is it's going to be very difficult for me to reach down through 3 feet of piping to reach any of the components in here. So that's why I have this 3-inch section here I can put into that cap. I have the male connector here, the female connector here, and then that connects to the rest of my bailing bucket system. So then what will happen is that when I need to work on this check valve in the future, there's a problem with it, I can simply unscrew it and I have access to everything I need right inside. There's no need to cut the pipe. There's no need to fiddle with trying to reach down inside a long tube to access anything. It's all right here and it's much easier to work on. I would just have to make sure I put some Teflon tape on there to make sure it doesn't leak on me, which isn't a huge problem because I am just operating right inside of a well. But that's it. This is just a very simple system, and it probably took me all of, I don't know, less than an hour to put together. I actually spent more time in the store finding the components than anything else, specifically the stainless steel hardware. I have stainless steel hardware throughout this just to ensure that this offers a good long-term rust resistance. So after you fill up your bucket here, depending on who's utilizing this, maybe it's too difficult for certain family members to really flip this around. They can just pull this over to their bucket and just hit up that switch, and it empties everything out. So yeah, let's try and do that again. That's simple, guys. So I want to thank you for watching, and I'll catch you in the next video.